A session on IoT convergence and connectivity, led and moderated by my good friend Robin Woolley. Robin is the founder and chief principal at Beecham Research, one of the best known analyst firms in the IoT sector. So Robin, take us away.
Very good. Yes, I'm Robin Woolley. I'm the CEO at Beecham Research, which is an analyst company specializing in the IoT sector. So I'd like to call on my panelists to join us. So that's Ronil Bahl, who's president and CEO of Core, Rick Somerton, who's CEO of eSAT Global, and Jörg Wolf, who's a digital business consultant at A1 Digital. Great. Great. So I think just as a brief introduction, so Ronil, if you could just say who you are basically, and what you do, and what Core does, and then Rick, if you could join as well, and then Jörg, thirdly, to just introduce yourself very briefly. That'd be great.
Sure. My name is Ronil Bahl. I am CEO of Core Wireless. Been here about 6.5 years with the company now, as we've transformed from sort of a pure IoT connectivity provider to providing connectivity solutions and analytics.
I'm Rick Somerton. I'm the CEO of eSAT Global, and we actually provide a proprietary IoT network for connectivity. We provide an end-to-end system using geosynchronous satellites.
Yeah, my name is Jörg Wolf. I'm a digital business consultant at A1 Digital. I'm in the company since about 2 years. And we do everything from managed connectivity over IoT platforms to our own cloud system. And we operate our own networks in Austria and over the Balkan.
That's fantastic. Thanks very much. So this discussion is about bringing together low-power satellite and 5G and what's going on in that area. So I think to kick it off, Ronil, if you could just give us a very brief outline of how you see the standards developing and 5G getting together with satellite and stuff like that, before giving any opinions on whether you think that's good or not, just to give us a
just set
facts.
Context. I'll let Rick provide the opinions, because by golly, he's got some. So, so if it wasn't complicated enough for those of us trying to connect things to have 2Gs and 3Gs and 4Gs and 5Gs and a 6G on the horizon already, and then you had unlicensed cellular, and of course you've always had sort of Wi-Fi out there and other, the sort of LPWA type IoT-specific, M2M-specific networks that have been launched. I mean, it's just a gobbledygook of vocabulary, and that's before you've left the world of cellular and terrestrial. Now you introduce satellite, and there's all these interesting things happening, right? The smaller birds up there, this LEO thing, right? Low Earth orbit, what it's supposed to do to help us with latency issues, these reusable rocket launcher things, and on and on and on. And the promise of satellite now in the world of IoT and 5G has never been stronger. So our customers need more advice than ever on what is the right connectivity strategy for their use case, is sort of the simplification of, if I boil that down.
Yeah, that's very good. That's terrific. Now, I don't know whether any of you want to ask questions or not, but if you do, there is a microphone at the back, so I understand. So put your hand up, and then we'll get a microphone to you. In the meantime, we'll carry on anyway. But if you do have a question, that'd be great to break it up a bit as we go along. So I think my first question is, which is probably going to go to Rick initially, is. How do you expect the convergence of 5G and satellite to change the IoT market in the near and longer term? I think it's the near and longer term that we're interested in there. How significant do you think this will be?
Thanks, Robin.
That's great. Now,
well, Robin knows my views already. It's a start. So we started the process, but it's wrong. So that's basically where I'm coming from. And what's happened is that the non-terrestrial network standard in Release 17 really just shoehorns in the NB-IoT waveforms and protocols, and it's very inefficient. you can handle inefficiencies when you're running terrestrial networks because you've got unlimited access to power. You can always infill with new base stations, and you're not limited in the number of beams that you can actually put down on the ground. And so in a satellite scenario, you have to be very sensitive to the constraints of the satellites, even if you're putting up thousands of satellites. Because if you're putting up thousands of satellites, then you've got to get huge amounts of numbers of devices connected to support that, and those satellites fall out of the sky every 5 years, so then you've got to recycle as well. So having a very inefficient system right now, as NTN's proposed, is not going to provide a solution to anyone in the short term, is my view. And to give you an example, I looked at Blues Wireless have a new offering here. They give you 18K of data for a year when you buy their StarNote. When you buy their note card, you get 500 megabytes. That's more than 3 orders of magnitude difference in the amount of data that you get. So they said you can send a message a day. Well, there are some applications for a message a day that's going to work, but you need to have something better. So we think that we have something better at eSAT. We're implementing it in March, but we've also signed up with the mobile satellite operators in setting new standards that will actually work for satellites. But it's never going to be you take your phone out and it works wherever you are, because there's just a thing called physics.
Great. So I don't know, Jörg, would you have a different view, or would you subscribe to that? Or
Yeah, for us as owners of terrestrial networks, for us it's closing the gaps, but only for sensors, because as you already know, the bandwidth is so limited here. And so my view is more like a hybrid system. So
Right.
we have a lot of tracking cases where we need reliable connectivity out of the network, so on the seas and so on. But we have a lot of limitations here. Yeah.
Yeah.
But it will close gaps, definitely.
over time, perhaps?
Over time, or it
Yeah.
depends on prices, of course, because if it's too expensive, nobody
Yeah. Yeah.
will invest.
I mean, is it fair to say that satellite is the missing link in IoT that needs to come together with cellular somehow? Is that a reasonable supposition, or do you think that it needs to be kept completely
Well,
separate?
for the non-Australian to say this,
Yeah.
right? I mean, certainly if things in Australia need to get connected, right? I mean, think about this, right? This continent, really, it has, the populations around the edges. That's where the terrestrial networks are. What happens to everybody else? So, for all of those rural, agricultural use cases and so forth, yeah, it'd be nice if satellite got there. It will take its time. Convergence is slowly happening and will happen in the LPWA, sort of lower power, right, lower bandwidth area faster, just because it's easier and cheaper. So I agree with a lot of these things people are saying, but I would still say that the nirvana, the goal, still remains convergence. We're solving for these use cases today just by putting multiple SIMs into a device, right? So when our customers' drones have to deliver mission-critical stuff, COVID vaccines, tests, whatever that stuff is, into Malawi, into the Democratic Republic of Congo, into the Shetland Islands and north of Scotland. I mean, you need both a terrestrial, a cellular SIM, and a satellite SIM, because without that, that bird comes down crashing to the ground. So, so we're solving for it. It'd be nice if, things started to come together, yeah.
Yeah, sooner or later. And so what sort of applications do we think are likely to be the first ones that are brought in with this
Sensors.
new nirvana of satellites?
Sensors and measuring levels of rivers, basins, whatever, weather data, and so on, and just to get a better data quality, to have more sensors in the ocean, in the air, in remote areas where we definitely have absolutely no coverage of the terrestrial networks. I think that will be the first, because people pay for the data, so that, in my opinion, will work first, yeah.
So what sort of applications would that be, though? Would that be remote monitoring or tracking, or?
Tracking is maybe two, but you have to have your clear view to the sky. And as we discussed, if you have it on a container and you have the container on level 0 in a ship and you have 40 containers stacked up on this, it's impossible to have it.
Yeah.
And I think meshing will take its time.
Yeah.
But I think sensors like the buoys in the ocean, getting temperature data, salt density, and so on, that could be something I could imagine be first.
So Rick, you're keen on agriculture, I understand. You think that there's some opportunities there?
Yeah, well, certainly remote is really where we see satellite having benefits.
Yeah.
That's pretty obvious. And I was just at the World Ocean Forum about 2 or 3 weeks ago, and the number of all these environmental guys are sitting there, and they don't have a baseline, so they can't measure the data and then work out how they improve the condition of the oceans. So there's going to be a lot of data requirements or data collection in the oceans. That's got to come from satellites. There's safety at sea. We've got a product with a man overboard. There's 100,000 people lost at sea every year. That's an amazing number.
Yeah.
And with a very low-cost tracker, we can save a lot of lives.
Yeah.
But we see agriculture. We're developing a satellite-connected cow tag that will have a total cost of ownership of around $10 per annum.
Oh.
That device will deliver a benefit to farmers of somewhere between $50 and $100. Because not only does it provide tracking and location of the cows, it provides traceability, and it also provides, with an accelerometer, an ability to understand the condition and the health of the animal, and to the extent that you can tell if a cow's calving, and if that cow's in distress, you can get out and help it in its distress. 7% stock losses for cows in calving. So you reduce that by 1 or 2% in a country like Australia, and it's a $600 million benefit.
Wow. But that has to be in real time, doesn't it, to actually be effective?
Absolutely.
Yeah. So it has to be quick up, quick down. So that's a geo type of situation, I'd have thought.
Well, yeah. Well,
Oddly enough, that's what you do.
The LEOs say they're going to do it, but they've got to put a hell of a lot of satellites up in the air.
Right.
And we've got coverage already with the geos that we're using.
Yeah,
and
okay.
Yeah, it's 2 seconds.
I just sort of making it clear that you're talking from a geo perspective. So I think that's
Thank you.
it's
Yes.
useful to just state that. Yeah. So Ronil, what would you think of the applications?
Yeah, no, look, I mean, if you generalize across what everybody's saying, it's what I said, right? It's the LPW, it's where the low bandwidth use cases are in the remote places where there aren't terrestrial networks is where this is going to start and converge, and it's going to come from there. All this really sexy stuff that the MNOs want to put out there, right? These high-powered applications with, all this artificial intelligence in the back and all that. It's not coming in a satellite world for a long time. I mean,
Right.
if you think about the amount of data that has to go back to some AI engine for the learning, right, the training of the AI engine to happen, it's not there. So it's the sensors, it's the low bandwidth, it's CC in the world of satellites going to be connected cows, not connected cars.
I like that.
That's great. Okay, but do you think that tracking is a big opportunity?
Yeah, no, and it has been. It was actually where I think satellite really got its start was those maritime use cases, right? You take stuff out of your warehouse, you put it in a container, it goes on a barge or a train or something to a port, and the minute it leaves the port onto the ocean, you lost it. So that's where it really, I think, came to life.
Right.
And I think Africa, and it's going to drive. But there's just no question that in 5 years and 10 years we'll be having a very different conversation. It's coming. Convergence is coming. It's just going to take a while.
So do you see the difference in benefits between a LEO and a GEO?
Oh God, Rick.
Or I could push that off to Jörg.
Oh, Jörg, please. You're not talking enough, my
Right.
friend.
No, for the LEOs that are, as we see with Starlink, that's something more for the end users, so for the high performance user, but that's not low power, definitely. So a Starlink system uses 75 watts for the antenna, and you have to have the clear view to the sky. This is nothing for a sensor.
Right.
You can't bring in 75 watts over 24 hours all time with a solar system. That's something impossible. The prices are pretty good, of course, and you have a huge bandwidth, but that's not needed for the IoT use cases.
Yeah, yeah. Okay.
So you can use them to support.
Yeah, of course you can use them.
Put a LoRa network or gateway in and
Definitely.
have sensors, but the range is very limited. So then the use case are limited.
Definitely, yes. So 5 years ago, it would have saved me a lot of stress because we had a construction site in the South Pacific with absolutely no connectivity, and it cost a huge amount of money to connect that construction site there. And yeah, Starlink would have saved us a lot of stress.
So when would you expect the costs to come down, do you think? When would you expect it to be a mass market?
When we launch. That's March next year.
That's what you're saying, yeah, yeah. Would you have a view about that, Gromel?
Yeah, I mean, again, look,
Timescales.
For the smaller bandwidth stuff, I mean, it's pretty much there.
Okay.
Right? You can launch, you can justify satellite instead of doing a big LoRa setup out on a big ranch or a big farm or what have you. It's getting real close. The higher bandwidth, again, I'm going to say 5 and 10 years, and a lot of people won't like that answer, but I said 5 and 10 years when 5G was being hyped when I came to this company 6.5 years ago, and I was right. So
right.
Yeah.
Yeah,
it's longer than we think.
It takes longer than you think.
Yeah.
To get it right, and it's not just the use of the technology; it's the size of the devices as well. I mean, I think you've been talking about very large devices for cows.
Oh yes,
yeah. Maybe that was in jest. I don't know, but
yes, they weigh 20 grams. That includes the weight of the battery in the case.
Yeah,
so the battery in the case are about half the weight,
yeah.
and then the electronics are about 10 grams as well. So
yeah.
pretty small, but we're working on making it lighter and smaller as well. But so Romy, there's actually we do have a connected car as well. So we've got a customer in Africa.
Oh.
They have huge problems with cars being stolen, and the little bit difference there is that the cars get stolen with the occupants, and so there's a higher level of urgency in tracking them. And you can't actually buy a car in Africa or insure a car in Africa without having a tracker in. But the tracker runs out as soon as you're outside cellular coverage, and so a lot of cars find themselves in Namibia,
right?
Because they just across the road.
Where's this happening?
In South Africa.
Oh, okay.
So we've actually got a customer that wants about 2 million devices.
Right. And Jörg, you were talking about Starlink and the use of Starlink, which is a big device at the moment, but then that's for very broadband.
Yeah.
Yeah.
Like this? Yeah.
Yeah. But that gets a good service.
They have a good service.
Well, I don't want to be an advert for Starlink, particularly in the presence of eSAT. But
yeah, it heats. It's as I said, it's 75 watts, so it's more as a stationary system. But yeah, it works absolutely.
And that's a Leo.
It's Leo, yes.
I just wanted to emphasize that that's a Leo rather than a Geo.
Yeah. And they have a lot of satellites in the air already, and they will, I think, 40,000 in the end.
Right. Yeah. Would you see any advantages of Leo over Geo? Because I can't ask Rick that question.
I don't care because we don't operate these. We just use the service and we do roaming agreements with that. And whatever technology works, I'm totally agnostic to that. So,
but fundamentally, it's latency, right? I mean, Leo,
yes,
lower orbit, closer to the Earth. It's just sort of physics, right?
yeah, but
you've got to worry about the number.
It's interesting when you talk about latency because I was watching a video last night from Gatehouse.
Yeah.
And they were talking about sending messages and just how long it takes to send a message because of all the handshaking and stuff, that there's not much advantage over Geo. So because of the complexity of the NTN protocols, the round trip time's probably about the same.
Oh, really?
Yeah.
It also depends how many LEO satellites there are in that constellation.
Well, yes. So if you don't have a full constellation, then you could be. There are some that are an hour apart. So that's the offering.
Yeah.
But on the LEO, it depends where the data gets down to the downlink station.
Yeah.
So, like Starlink, they always route you to your home country. So if your system is registered in Germany, wherever I am on the planet, the data comes down in Germany.
Yeah.
And so the latency is uncalculatable. So
So I'd just like to also just spend a few minutes talking about the technical issues of coverage and landing rights and stuff like that, because that adds to the complexity of satellite systems. Rick, I don't know if you can just give us an outline of the issues involved, because you may be able to physically transmit to a country, but you may not have the rights to have the stuff come in that country.
Well, that's right. To all the new entrants coming into the market, they actually have to negotiate access rights in every country that they're going to, and they need to get spectrum. So we work with operators in L-band. They already have global spectrum. They already have arrangements to land in every country in the world. So it means that when we switch on, we've got global coverage. And so that's important. It'll take a long time for any LEO operator to actually get all of those approvals that they need around the world.
Yeah, yeah. Would you have any additional comment to make on that?
No.
Too technical for me, he says.
We've covered a lot of technical issues, though, haven't we? I mean,
Yeah.
everything from battery life in a very light device. How do you get both of those things, right? The data, the bandwidth. I mean, those are the constraints. So
Yes, yes. So really, it's a sort of closing now as what we think the expectations are for the next, not necessarily the next 5 years, but the next 10 years. What can we look forward to in 10 years' time? Will we have a close integration between cellular and satellites? Will it be part of 5G, or will it be part of 6 or 7G or something like that? Or and are we going to have? Is it going to be LEO or is it going to be GEO? Does it matter? So paint a picture. I mean, I think your pictures would be interesting for the audience as well. I'm kind of assuming that you don't want to ask a question, by the way. So if you do put your head up. No, okay, great. Let's carry on.
So from my agnostic view, as we are not operating satellite networks, it's just the expectation that we can close the gaps.
Right.
Whatever technology it is, so we already started with 4G systems to have a connection to satellites. Whatever it is, so we will try to use it, to have roaming agreements. However this will work,
Right.
we will have to work together with the satellite operators and close the gaps. So if we have customers that want to get meteor data from anywhere in the world, so we can help them.
Right.
That's it.
Rick, what would you think the future is in 10 years' time? Do you think there'll be a close integration, or do you think it'll still be proprietary satellite and cellular?
I think there'll be improvements in the standards, whether that's a separate satellite standard or it's part of 3GPP. We'll see. Right. But there's certainly one of the things about the standards is going to be interoperability between satellite operators. So then it doesn't really matter whether you've got LEO, GEO, or MEO.
Right.
If you've got a standard and everyone's operating the standard's been developed to accommodate each one of those heights or altitudes, then it doesn't matter. And then you've got the benefit of the commonality of the standard and the hardware coming out. So you develop to the standard, and it's much easier. And so there's sense in the standards.
So, Ronil, the final word from you.
Yeah, I mean, look, again, of course, things will get better, and again, they'll get better from the low bandwidth, working our way up. I believe in an agnostic type world. That's what core is. We help our customers sort of regardless of, what carrier, that. Frankly, customers shouldn't care about 2G or 3G or 4G or 5G or 6G. They should care about, I need this much data, I need the device to work, I need to get my data, I need to get on with my insights, I need to run my business. In the same way, that's exactly what Rick is saying. The satellite guy, somebody, the MVNO of the satellites will figure out how to, sort of simplify across those, orchestrate across those complexities and just make it consumable. Right. And remember, even in the terrestrial world where there's pretty standard 4G and 5G networks coming up all over the world, it's still darn hard to make a global deployment work, right? The stack agreements, the roaming arrangements, the business arrangements. And so satellites got to go through all of that maturity yet, and it will be 10 years before
it'll get there. It'll get there.
Yeah.
Okay, all right. Well, there's an optimistic story for everybody. That's the end of this session. So thanks very much for listening, and hope you actually learned something from that. Great, cheers.